me to stop recording at the end of the period, because when I make the little button go away, I forget all about it. All right, so also you may want to keep an eye on the time, because I think they're going to turn off the bells because they're officially star testing. So, you know, if y'all don't stop me, I will just teach forever, which is delightful, I know, but there will be, Ranger will be standing outside the door wanting to get in because he'll want to learn. And also, when you leave the class, please don't just tear out of the room and go screaming down the hallways like y'all always do. And then go to your next class, and if there is a note on the door that says go to the gym, go to the gym. But if your teacher's there teaching, go learn something.
I nap for the next 3 periods.
Maybe you can nap in the gym. I don't know. I don't know if they'll have room for y'all guys in the library or wherever you go next. All right, so we were about to start on problems 15 through 26, and we're writing as the cofunction of a complementary angle. So if you need to look at your cofunctions, we wrote them on this back page where we are building this fabulous copy of all of the rules. And cofunctions, here's the deal, Lucille. You have an angle, okay, and then you have an equation. The other side of the equation is the cofunction with the complement. United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Now to the Texas flag.
Honor the Texas flag.
I pledge allegiance to thee, Texas, one state, under God, one and indivisible. Please remain standing for a moment of silence. Thank you. You may be seated. We do not prop doors open on this campus for any reason ever.
No
if
door
you see a door propped open, please close the door for our safety. And teachers, please check for dress codes. If there are any issues, please send the student to the office. If anyone is interested in yearbooks for next year, please sign up in the office.
Y'all are so. It's only to have a.
And juniors, you can go to the practice gym at 8:30. Today is job picture of birthday and National Zoologist Day. That's all. Thank you. Have a great day.
Okay, so let's see what these guys look like. All right, number 16. They ask me, or they give me, whoa, that's not what they give me. Because
if that's your number in baseball, you're probably pretty awesome and crazy good.
Does your number mean something in baseball? They don't just randomly hand you a jersey with a number on it?
No, I picked my jersey. I got Coach up to order it. He wasn't going to get 16.
Oh, so you're number 16.
Yeah.
I
That's
got
why
you.
I said he's probably super awesome and great at the game.
Okay. Now, there's a lot of things we can do with sine of 15 degrees, including using the sine rule for sums or differences, but I haven't told you that rule yet, and the directions want me to use a complementary angle. So, I need to also use a cofunction. What's the cofunction of sine? Cosine, but the cosine and sine don't match for the same angle. They match for complementary angles.
90 minus 15.
So if we did 90 degrees minus 15 degrees, we would come up with how many degrees? I'm writing really small here. Can y'all see that if I write that small? Okay, so those are equivalent, right? I don't know that you even needed the parentheses there. I really didn't have a need to wrap parentheses around that argument, but my hand felt like doing it, okay? Now, pretty friendly when they use degrees because you just subtract from 90, right? But what if we have an example like number 18 where I say, what is the sine of 2 pi over 5, restate it with an equivalent trig function that is the complement, a cofunction of a complementary angle? Huh?
Would you do it like pi over 2 and then get a common denominator?
So we need to, so first of all, sine again is going to be cofunctions with cosine. So you are changing the trig function and you are changing the angle to its complement. So in this case, I would need to say pi over 2 minus 2 pi over 5. Agreed? Would you like to use the r square rule? So what's the denominator going to be? What am I going to have first? 5 pi. Then what am I going to have second? About minus a 4 pi, which leaves me with what? Pi over 10. So the r square rule, is that helpful or did you already just know that? Kind of knew it, kind of did it. Okay, r square, thank you very much, r square. All right, moving along, that's all we're going to spend on examples of those because they're not rocket science. So we're going to move to the next batch of problems, which goes from 39 through 46. And let's see what they want us to do here. They say to use an identity to write whatever they give me as a function of theta. Okay? So, use an identity. Well, we've got quite a few identities. We've got the sum and difference rules. We've got all of our Pythags. We've got our recips. We've got quotients. We also have our cofunction rules. All right. Got lots of good stuff. We even have our positive and our negative angle identities. All right. So in the end, they want your answer. And let me just double check that by looking at a batch of these. They want it as a function of theta. Why does this not look like that? Because I'm in 5.3, but my book is still in 5.2. Okay? So, I just want to confirm what I'm about to say to you. What I think I'm about to say is make it just a single function. All right? So, now I've got to remember which problems there are. 39 through 46. Yep, you're just turning it into a single function of theta. Okay? So, how did I word that? Okay, write as a function of theta. Okay, ready to try a couple of these? Number 40 comes at us looking like this. They have given me the cosine of 90 degrees minus theta. Well, what sort of identity do you think we're going to use there? Okay. So what are we going to do with it?
Sine of theta.
It just simply is the sine of theta. So that was pretty easy, right? Let's try out number 42. Huh? Can we box it? Is that what you said? It is boxed. I would box it. It is done. 42. This says the cosine of 270 degrees minus theta. Is it a cofunction? Is it? Cofunctions always use
90.
complements, and that's not a 90. So have we learned anything else that would involve the cosine of a binomial that may have been a sum or a difference? Perhaps. Maybe we could say this is our A, this is our B, which brings us right back to what we learned yesterday, right? So this would be the cosine of a difference. Did I hear a knock on my door, or am I imagining that? I did hear a knock on the door.
Can I borrow a Chromebook for testing for Miss Gardner?
Yes.
Huh? Oh, never mind. I found one. Good. Thank you.
All right.
They lied back to teaching.
Okay. So, what is the cosine rule? What do you know? What do you know for the cosine?
Cosine, sine, sine.
Cosine, cosine, sine, sine.
Op-
Opposite in the middle. Okay? So, we're going to say this is equal to what? Which is a thing. We can figure out that, right? Times. Okay. Can't really figure that out. I don't know what theta is, but it's okay to end up with a theta in my answer, right? Then what goes in the middle? Plus what? The sine of 270 times the sine of theta. Well, that's not looking like one function there, is it? What happens next? What is the cosine of a 270 degree angle?
So it's down.
Is it 0? Because it's your x move, right? 0. So what's going to happen if I have 0 times the cosine of theta?
0.
That's just going to go away. And over here, what's the sine of 270 degrees? Okay, I'm just going to put that in parentheses since I put a plus sign anyway when thinking about it. What's the sine of theta? It's sine theta. So if you cleaned all that up, what would you have? Do you have your answer written as a function of theta? Nobody said it couldn't be negative, did they? Okay, so play around with those and we move on to problems 47 through 52, which are not going to fit in this space. They take up some real estate. They take up about half a sheet of paper. So if you don't have about half a sheet of paper, turn the page and you will have about half a sheet of paper, okay? We good? Okay. Takes a little bit of doing here. These are problems 47 through 52. They say find the cosine of s plus t. Now, s and t are not my favorite variables because a lot of times my s's look like a 5 and my t's look like a plus sign. So do something to make sure that they do not look like other things, that they look like the letter s and the letter t, okay? And that's not enough. They also want you to find the cosine of s minus t. And you're going to see these problems probably on your trig homework and also maybe on quizzes and tests and things like that. So here is the deal. Tell me first, what rule do we have for cosine of s plus or minus t? Because it might be very helpful to have that sitting right in front of our face. What's our rule? Okay, so, and using these variables, it'll be cosine of s times cosine of t minus plus sine of s sine of t, correct? So, in order to work these problems, you have got to find 4 little pieces. The cosine of s, the cosine of t, that is a very dark highlighter, the sine of s, and the sine of t, and they are going to give you some information to start with. So, we will do number 48 together. I have just decided that I no longer need the extra sweatshirt. This trig is getting real now. If I'm tutoring in the evenings and we get to some hard math, I usually end up taking off my sweater because I guess apparently my heart rate goes up and I'm super excited and now I'm ready to go. Let me get myself hydrated here. Are y'all excited about this problem? Yeah. Was that sarcastic? I don't know. Okay. So this is how I organize it, and I just need you to recognize them when they come up. They're not insane, but you need to recognize them. So what we've got here is they give me some stuff to work with. For example, in this problem, they tell me, well, the sine of s is 2 over 3. Oops, that should be equals 2 over 3. That would make more sense. And they also tell me that the sine of t is negative 1 over 3, but they very carefully don't put the negative on top and bottom. They just put it out in the middle. Now, 2/3, 1/3, those aren't trigonometric circle values, are they? Which means we're not looking at angles that are on the unit circle. Okay, I said trigonometric circle. I mean unit circle values. They're not our special values. So, I need to know the cosine of s. I need to know the cosine of t. They gave me the sine of s and they gave me the sine of t. But how can I find the other things I need? How can I take these and make cosines out of them? That's when we got to do the x, y, r thing, and we're doing it for s and for t separately. So, if we do the x, y, r thing for s, what do we know? And also, does it tell me anything else? Do they tell me this or did I assume this? Hold the phone. There may be more because I'm looking at my notes, not at my book. I'm looking at number 48. Oh, they tell me some more, people. They give me more. They tell me that S is in quadrant 2. And they tell me that T is in quadrant 4. Would that be helpful to know?
Yep.
Why do I need to know that?
Negatives.
Yeah, because sine is positive 2 different quadrants, right? So knowing sine is in Q2.
Means your x is negative.
In quadrant 2, my x should be negative then, right? Okay, do I know my x yet?
No.
Okay, but I'm glad I put the negative. What do I know?
Your y is 2 and your r is 3.
My y is 2, my r is 3. How will I go about finding my x?
9 minus 4.
Okay, square root of, right?
Yeah.
9 minus 4, which gives me what?
Square root of 5.
How about negative square root of 5?
I already have that written down.
I should have known because you are that good, okay? So, I already know the sine of s, right? Although I might want to just write them all together so they're handy to grab. So we know the sine of s is 2 over 3. And now can we find the cosine of s?
Yes.
So what would the cosine of s be?
Negative square root of 5.
All right, we have our players for s, right? So we come over to t. We need an x, we need a y, we need an r. We're in quadrant 2 now. No, we're not. I'm lying. Look. We're in quadrant 4 now. No one will ever know. So we're in quadrant 4. So what does that tell me about the x and the y?
Your y.
The y is negative, so the x is positive. What else do we know about t?
The y is, wait, never mind.
Okay, so I'm going to bring that up to here because that's my y, right?
Yeah.
So
And your,
y is negative 1
yeah. And then your r is 3.
and r is 3. So in order to get my x, I will be doing
9 plus 1.
plus or minus.
When you square it, it's plus.
But this is the hypotenuse, so I'm subtracting. So what about the square root of 8?
2 square root.
Now, can we get the sine of t, actually, can we copy the sign of t? Negative 1 over 3. And can we figure the cosine of t? 2 square root of 2 over 3. Now, we have to do two answers. First, we have to find cosine of s plus t, correct? Since I have the formula written right here, are you comfy with just plugging in the 4 values? Okay, so first we need cosine of s, which is what?
Negative square root of 5 over 3.
Okay, negative square root of 5 over 3. I'm just going to put it in parentheses, and that will multiply times cosine of t, which is
2 squares is 2 over 3.
and then what will be in the middle?
Minus.
Minus. And then the next thing I need is what?
I mean the sign.
Sine of,
S.
which is?
2 over 3.
Followed by,
Sign of t, which is negative 1.
all right, and then we clean that up, don't we? Would you agree that we're where we are yesterday and the common denominator of both sides is going to be the same? What are we going to have? Okay, my wording was not good there. The denominator of both sides is going to be the same, which will be what?
3. Oh,
9. So you got to be careful because we are putting adding fractions next to multiplying fractions. So don't forget to multiply your denominators. What would your first term be? And I made that excessively wide, and it may be wider than I actually need. Overkill. What's the first part on the top going to be?
Negative 2 square root of 10.
Negative 2 square root of 10. No buddies there, huh? And on the other side, what are we going to have?
plus.
Get plus 2 or minus negative 2.
Well, let's not put minus negative 2 because then we have to recopy it, right? So, how do you feel about that answer?
Good.
Okay, so that was the cosine of s plus t. But that's not enough because I need the cosine of s minus t. And do you think we need to go through all of this again?
No.
What is the only thing that's going to change?
Your sign.
Okay, what sign?
The one in the middle.
Yeah, because this would then be a plus times a negative, which changes this to negative 2 square root of 10 minus 2 over 9. Box that puppy, and you might want to note that that is the only change. Okay, so I think that wraps up my 5.3 note. So we move right into our 5.4 notes, which takes us back briefly, very briefly, to not last year's notes, but this year's notes. So we're going to come to this page that has a box. Okay, so by the way, this homework due tomorrow. Got it? 4-9 homework? Okay. 4-9 is tomorrow's date.
Wait.
Trig.
Why do you have it on there as Thursday?
Let's go with Thursday then. I'm fine with that because, y'all, I got plenty of stuff to grade as it is. I'm totally okay not taking in a new paper tomorrow, all right? But you don't have any other homework tonight, so don't put it off and let things start piling up because we're moving right into 4.3 right now, okay? 4.3, no, we're moving out of 4.3 into 4.4. I put the box of formulas all in the middle because they hang out with each other. But I'm just making up numbers, aren't I? First of all, we're in chapter 5, not chapter 4. Let's back all that up. The formulas for 5.3 and 5.4 are between the assignments for 5.3 and 5.4. Notice there are virtually no notes here, other than the fact that I know which problems I'm going to do out of the book. You have some practice problems if you want to check some odds in the back of the book, but you have a trig homework. I'll put a date on this trig homework. Probably sometime tomorrow I'll put a date on it. Okay? What we need are the new formulas. So tell me, how do you remember cosine?
Cosine,
Cosine, cosine, sine, sine. And opposite in the middle. Okay. The sine formula doesn't work that way. It takes sine, cosine, okay? A and B will always stay in order in the way that this book puts them. And it drives me nuts because some textbooks do not order these the same way. And so I'm tutoring students that don't order them the same way, and I'm like, what? What are you doing? They're all doing a formula, but they're not doing it in the order I'm doing it. It works out the same, but it drives me nuts. But I like the way this textbook goes with it. So it's sine, cosine. We do not do the opposite in the middle with sines. And then we mirror it so that it'll be cosine, sine. The A's and the B's don't change order in these formulas. Understand that? So, for sine, you need to remember sine, cosine, cosine, sine. So, what do you have to remember for sine? Okay, that needs to be in your head. Calculus people, look at me. These pop up in calculus. You will have points in calculus when you're messing with some trig functions and you're going, I don't know what to do, but if you would remember the sum difference thing, you can push through to the next step. Okay, so that's kind of a big deal. It's one of those things, you learn it, you don't touch it, and then it just pops up out of the blue a year later in your life, and you're like, oh, that was a thing, wasn't it? And you'll probably even say, I think I even remember Miss Stewart saying I needed to remember this. Okay, after you've searched the internet to find somebody who knows how to get to the next step in your calculus problem, then you go, where'd they get that? Well, they got it from trig. All right, what's the cosine rule for sums and differences? And opposite in the middle. What's the sine rule?
Sine, cosine,
same in the middle.
Yeah, same in the middle. Okay, so we good? All right, so let me see if I want to jump you right into the tangent rule as well. I do want to,
I bet it's a fraction
Why?
because it's a big space.
She is so intuitive. Yes, it's a big old fat fraction, as a matter of fact. And you can draw your fraction bar straight, or you can draw it wiggly like I did, whatever you prefer. Okay, now, this is all about tangents and not about anything else. So, in the numerator, you will have tangent of, guess what angle I'm going to start with? A. I am not going to do the opposite in the numerator. So if they give you a plus, you're going to plus. If they give you a minus, you're going to minus it. And behind that, it's all about tangent. So I feel like I need a tangent for B. Do you feel like you need a tangent for B? Okay. So then we go to the denominator, which starts with a 1, because 1s just seem to show up a lot in trig, don't they? Okay, now we didn't do the opposite on top, so let's do the opposite on bottom. So we have a minus plus on the bottom, and then, we haven't multiplied anything together, have we? So let's multiply, but it's all tangents. So guess what I'm going to multiply together on the bottom?
Tangent A,
Tangent A times tangent B. And that's not the most unfriendly formula ever, okay? And we're going to play with these. So we got all of our formulas handy. Let's go do some problems from 5.4, which is sums and differences for sine and tangent. We could have abbreviated those, but did y'all realize SIN, that is an abbreviation for SINE?
Yeah.
Gotcha. Okay, moving into some sample problems. Okay, 9 through 22. That's a big old batch of problems. They asked me, how long do I teach you? Till the 35? Oh, I got tons of time. Lots of Triggy time for you guys. You don't look as excited as I am. You're tired. Why are you so tired?
I did the measure grade yesterday.
The what?
The measure grade.
Metro grade?
the major grade.
Major grade. How late?
I don't know.
A long time. Did like suck all your brains out? And you haven't regenerated fresh new brain. All your brains are in the tray, is that what you're saying?
Well, I agree with you.
Okay. Plus, when you're approaching a break, somehow your brain just naturally wants to shut down in advance.
Yeah, I'm ready for break.
You're ready for break.
It's been the longest-
And y'all got a little bit of senioritis going. So are you considered a junior or a senior here?
I see.
A senior? Okay. Does that kind of coincide with graduating from high school in Italy, or how does, not at all?
I have another year of school in Italy,
Gotcha.
but we don't do anything like this. Like senior, just do a 3 big test at the end of the year.
Uh-huh.
That's it. You don't do like any prom. You don't do any.
Graduation.
Yeah.
Wow. You just move on to
Yeah,
what,
you do the
university
test,
level?
And then you have like a last oral test.
Uh-huh.
They ask you about everything.
You have to remember everything you ever learned.
Yeah, almost. That's it. They shake your hand and say goodbye.
Goodbye. And as you walk out the door, yeah.
Usually, a lot of people after they give them like the teacher give them the grade,
Uh-huh.
like insult the teacher. But yeah.
They will insult the teacher, like to their face, and once they safely have that grade.
Yeah.
Is that like a tradition and it's okay, or it's just rude?
Yeah. It's pretty rude.
You can insult me when you leave?
No,
Oh.
not at all.
Have you enjoyed this experience here? Have you learned? But has your English improved? You had pretty good English anyway.
Yeah, that's improved already.
Good. All right. Have you learned stuff from the other classes?
Like here
Yeah.
or something.
Yeah.
I'm like doing this because I need this.
Good.
Like I already did this, but I don't remember anything about it.
Good. Because if you do hit calculus soon,
I think I have it like next year. I don't know what calculus is, but
Good.
I have it next year.
yeah, calculus is it's like it's like taking algebra and trig and combining them into this. Oh, it's a beautiful thing. It's like the best of everything.
It's like derivatives. How it's called? Like what do we do in calculus?
Okay. Wait. What?
How
So
it's called? I don't know. I know in Italian, but not in English. The word.
okay. So what do you do? Like what sort of stuff do you do in
Yeah.
calculus? Okay. So calculus is about. Let me just give y'all a little wander here. Okay. Y'all okay to wander?
Yeah.
Okay, so we know all about slopes of lines, right? And slopes are constant on a line because the line has a constant rate of change, right? But in calculus, you start, one of the main things you deal with is what about curves where the slope changes? All right, so slope You've heard that called a rate of change. Maybe in your algebra somewhere that's an E, sorry. Okay, so let's say that this was over time, that's your x-axis, and this was maybe your speed.
Distance.
Yeah, let's make it distance. Let's make it distance. The distance you have covered. So as time goes by, you covered this. That's not going to work nicely because your distance won't go down. Let me think of something else that happens over time.
Height.
We,
Age over time doesn't really do, okay. I'm trying to think that something we could see. Let's go with speed.
yeah, I think so.
Let's go with speed, okay? So, if you are, I was gonna maybe putting like miles per hour, that, I don't like having the double thing there.
Yeah, that's what I was
Yeah, so it's a rate
You can do
as one
speed
of,
and distance.
thinking. That one.
yeah, but again, distance isn't something I'm having a hard time coming up with just don't worry about whatever we got for now. But, here, what's the slope of that graph?
The
Well,
slope.
the slope is very different. At this point, the slope is increasing, right? But when you get here, it's slowing down, and you get here, the slope, there is no slope, or excuse me, the slope is 0, and then you start having a negative slope. All right? So in calculus, we're not expecting things to be constant. For if you have a speed, you do not drive a constant speed forever, do you?
I kind of just tossed it on cruise control and go. I don't know.
Yeah, but something's gonna happen. So if you
Yeah,
decide
cruise
to,
control
if I decide to drive to Georgia and I set my cruise control for 70 miles an hour, I'm not even gonna get over the Sabine River Bridge before something slows me down or something tells me that I'm gonna need to speed up, okay? So in reality, these constant rates of changes are not nearly as common as fluctuating rates of change. So to find slope, you could use some algebra. You could pick 2 points and connect them with what is called a secant line, okay? And you can find the slope using a slope formula, you know, y2 minus y1 over x2 minus x1, delta y over delta x, you could use that, okay? But that's just estimating your slope, because at somewhere along that curve, that slope really is actually just like that. But all the other places along that curve, that slope is different, right? So calculus leaves the world of just algebra skills and teaches you to find a point. So not an average rate of change over a bunch of points, but it picks one point and says, what's the slope right here? And that is called not the average rate of change, that's called the instantaneous. In this instant, what's my slope? Okay? Well, that little slope line is a tangent line, because a tangent line only touches a curve at one point, which you heard back in geometry. You would have a point and a tangent line. But if you crossed your figure in 2 places, you had a secant versus a tangent. Does that sound familiar from geometry? Okay. Calculus wants to know what's the tangent line, or what is the slope at that point. And so it has a skill called a derivative. And that is a calculus skill. And so to get a derivative, you have to learn a lot of background of definitions of derivatives and go through a section that everybody hates called limits. And you don't get to go to the derivative until you endure the limit. But one day, a few weeks into calculus, suddenly you stop doing limits and you start doing derivatives. So I could look at a function like maybe y equals, that could be a cubic function, x cubed minus 5x squared plus 2x plus 3. And I could say, what's its derivative? And the derivative is a new function that if I plugged any x value into that function, it would tell me the slope at that point. So instantaneous rates of change. So I could, and it's nice to know, calculus was invented or created, or I would use the word discovered, because I think the general mathematical concepts were out there, just humans had not developed to the point of going, oh, we could do this. It was discovered by two different mathematicians within a 50-year period of each other in two different countries. So one of those mathematicians was Sir Isaac Newton. So during the Black Plague in Europe, one summer it got so bad, you know, because that's when the plague would spread worse, that they closed down Oxford in England. All right, is it Oxford? Okay, they had to close it down and send all the people, say, get out of the city, go out to the countryside and be healthy. All right, kind of like our whole COVID thing. You know, go home, be healthy, keep your germs to yourself, right? So, what did y'all do during COVID?
Play Fortnite.
You played a lot of Fortnite? Okay. Well, Sir Isaac Newton, who wasn't Sir Isaac Newton at the time, did not go home and play Fortnite. He went home and he discovered the 3 laws of motions from physics, you know, like an object that stays at, you know, is at rest, stays at rest, an object in motion, you know, those laws. And then he got bored because that wasn't enough, so he also created calculus.
But could he crank 90s?
Could he what?
Crank 90s.
Could he crank 90s? I don't know, because I don't even know what that means. So, anyway, I'm going to go with no. We all have our own specialties in life, right? So, at the same time, this German guy, whose name I cannot pronounce, so I'm going to say Leibniz, but I don't know if that's correct, came up with the same general theories. It was like humanity had developed to the point where they were ready to discover the next thing in mathematics. And if those guys hadn't figured it out, somebody else probably would have figured it out. But if nobody would, you wouldn't have cell phones and you wouldn't have most of our modern conveniences have calculus wrapped up in them somewhere. But anyway, they both discovered this concept of a limit, which you will hate when you do it, but just suck it up, because then you can get to the calculus. So you have two notations. So this is why my derivative, and I can't remember which one is Newton's versus Leibniz's notation, but you might say it's dy dx, which is the change in y over the change in what, kind of like delta y over delta x, which finds your slope, right? Dy dx, or you might go with the other guy's notation, which is just say, hey, y prime is the derivative of y. And then you can look at that and you can derive it and go, oh, well, that's 3x squared minus 10x plus 2. And then I can pick any x value, plug it in. So, and then I can tell you what the slope is at that point.
How'd you get that number?
I did a derivative. I used some calculus.
Oh.
So what happens in calculus is, a lot of times your calculus takes up one line on your paper. And you have to spend 2 or 3 rows of algebra skills just to make the problem calculus friendly. And then after you derive it, sometimes you spend half a sheet of paper using your algebra skills to clean it up. And then I'd say maybe somewhere between 10 to 20% of your problems will have some trig in them as well. Except for you, because business calculus doesn't do trig, but it does do these derivatives.
Yeah, I'll do this next year.
Huh?
I have to do this next year.
Then, you're taking a good trig toolkit with you, and I'm hoping your algebra toolkit is good. We did it last semester. When was the last time you did algebra? Before you got on the plane?
No. Like 1 year ago.
Okay. Are you strong with your algebra?
No. Not at all.
Oh, no. I wish you'd come in the fall and would have been here the whole year. So, anyway, okay, guess y'all are telling me by packing up that there's no bell and that we're done for
Yeah, it's
today.
like 36, I think. Now.
Okay. Goodbye, teenagers. I'm gonna stop the video now since nobody, yeah, thanks. You're a big helper. I can't even find my mouse.
Bye.
Goodbye.